Hello, 8th graders. Notice that we are skipping ahead to lesson 13. It's called the definition of scientific notation. And we're going to be continuing with scientific notation to write large and small numbers. Remember, large numbers might be something in space, like distances between planets. Small numbers might be something like the size of cells or bacteria. Here we go. Okay, on these problems, I've written the 10,000 or the 1,000 or the 100 or the 0.01 as 10 to a power, like we've been working on. And that's helpful because if you look then where your decimal starts out, like in your first one here, it starts out here after the 3, then I would just move that decimal to the right 4 places and add in those 4 zeros. So it corresponds to that number in your exponent right there. On the next one, if I start with 3.4, then I would move it 3 places to the right to make it larger, and I would end up with 3,400. In the next one, if I start with my decimal at 0.6, I'm going to multiply by 100 or move it twice to the right, and I end up with 60. And in the last one, if I start with my decimal in 7.3, I would move it 2 places to the left since it's a negative exponent, making it smaller, and I would end up with 0.072. Before we start this next activity, I want you to take a few notes here on the scientific notation rules. So this is just how do we properly write numbers in scientific notation. The first rule is that the first digit in your number must be 1 through 9, so it can't be 0 or 10. It can be positive or negative, but something 1 through 9. So, for example, the number 2.43 times 10 to the 4th is proper scientific notation. I'll give it a green check there. But the number 0.243 times 10 to the 5th, if you expanded it out, it would be the same number, but this is not proper scientific notation because that first digit is not something that's 1 through 9. So just keep that in mind. That's really the biggest thing about writing scientific notation properly. The other rule is that your number must then be multiplied by a power of 10, and that's what you see happening every time we're writing these numbers with powers of 10. Okay, so in this activity, you're going to see this crazy looking number line like this. This is just a way that we can use scientific notation on a number line. Essentially, these arrows are showing like a zoomed in portion of the number line. We're not going to worry about this very much right now because we don't need it. So move on to the questions with this activity. All right, in this table, the two that are written in proper scientific notation are the speed of light through water and the speed of light through ice. The rest are not written in proper scientific notation. So we are going to do that. I first want you to try to do space and copper on your own, and then we'll talk about them when you're ready. Okay, there are the ways that you would write those two in proper scientific notation. What happens is that if I put my decimal right after the 3, so that my first digit is between 1 and 9, I could see that I would need to move my decimal 8 places to the right to get back to my expanded form. So then that means it'd be 3 times 10 to the 8th. Very similar down here for copper. I would put it right there. So it's 2.8. So my first digit is between 1 and 9. And if I moved it 8 times, I would get back to my expanded form. When we get down to the example for diamond, this number is not in proper scientific notation because our first number over here on the left of our decimal is not between 1 and 9. So what I would do as you're starting out doing this is I would expand this out. So this number written with my 6 zeros would look like this. Now to put it in proper scientific notation, my decimal would go right here behind the 1 so that my first digit on the left side of the decimal is between 1 and 9. And then I would write that as 1.24, and then the rest of it can be covered by using our power of 10. Now I would see that I would need to move my decimal 8 times to the right. So the proper way to write this in scientific notation would be 1.24 times 10 to the 8th. Okay, now for olive oil, I did the same thing right here. I expanded it out. I moved my decimal to the right 9 times. and then simplified it. So this is what I have. Now, if I'm going to put this in scientific notation, I would put my decimal right after my 2. And so this would be 2 times 10 to the 8th. So that is those numbers written in proper scientific notation. We're going to do a few more examples here. Okay, I want you to write these examples down somewhere to have as part of your notes. The first one is not in proper scientific notation, 24.1 times 10 to the 3rd. And it's not in proper scientific notation because to the left of our decimal, this is not between 1 and 9. So if I was going to put this in proper scientific notation, instead it would be 2.41. And then that would need to be times 10 to the 4th. And again, if you want to expand this out, it would look like that, 24,100. And so if my decimal was right there, I would need to go 4 places to the right. You don't have to expand it out, but sometimes it can help as you're trying to wrap your head around where that decimal would go and what your power of 10 needs to be. Okay, our next example is 0.03 times 10 to the 6th. Again, not in proper scientific notation because right here I have a 0 to the left of the decimal. So to figure this one out, again, if you want to expand it out, that is perfectly fine. It would look like this. And that would simplify to 30,000, which if I wrote in proper scientific notation would be 3 times 10 to the 4th. Now again, you might be seeing a pattern on how your exponents change when you're moving this decimal to put it in proper scientific notation. So if you don't have to expand it out, then don't. But it's a good way to kind of check your work as you go. Okay, here's an example with a negative exponent, 15.4 times 10 to the negative 4th. Again, not in proper scientific notation because we have a 15 over here and it needs to be 1 through 9. So if I expand this out, if I move my decimal to the right 4 places, it would end up being 0.00154. And I'm looking at that number and I know that my decimal really needs to go right here. So 1.54. And that would be times 10 to the negative 3rd. There is a card sort activity in your book right after this. We're not going to do it with cards in front of you, but you are going to do it in a Desmos activity. It is some good practice working with more scientific notation. So go ahead and do that. And then after that, you'll be able to take the mastery check.